All right. Hey, welcome back to another week, guys. We're in week 5. So this week we're going to be working on absolute value equations and inequalities. All right. So all of those rules and things that we had to keep in mind last week when working those inequalities, we're going to be working this week as well. Okay. So, um, however, this is going to be kind of two parts this week. We're going to do um, lesson number 10 and 11 this week. So two lessons this week. First, right now, we're going to be working on the absolute value equations, and then we're going to be focusing on the absolute value inequalities in the second part of this week. All right, so let's go ahead and write these steps down. I'm going to give you guys some four really good points to think through in the process when we're doing absolute value equations, okay? These are going to be a little different than just simply normal equations in terms of how we proceed, okay? How we solve exactly the same way that you've ever solved any type of equation before. But here you're going to see that we write this equation twice, okay? So here's what we want to do. Step number 1, again, you guys write what I write, okay? Step number 1, we want to isolate the absolute value bars. Isolate the absolute value bars. So before I go, I accidentally just erased that. Sorry, guys. Let me do this one more time. Isolate the absolute value bars. So before we move on to step number 2, let's kind of see and wrap our mind around what that means. Okay. So isolate means to get something by itself, right? So if we're on an isolated island, we want to isolate something, we remove everything that's around it, and whatever has been isolated is now by itself. Okay. So case in point, if we look at example number 1, okay, because notice what I'm referring to. We're referring to the absolute value bars, isolating those absolute value bars. In problem or example number 1, that has already been accomplished because I'm specifically referring to whichever side of the equation the absolute value bars are on. So these bars right here deem absolute value. Okay, so we should have learned in the past that the absolute value of anything is simply the positive. Okay, the absolute value of 7 is 7. The absolute value of -7 is 7. Absolute value is telling us the distance away from 0. Okay, distance is always positive. That's going to be a key point that we bring out later in the semester. However, for our purposes right here, notice whenever I say isolate absolute value bars, in example number 1, absolute value bars are already isolated. So from there, we can move on to step number 2. However, example number 2, notice here are your absolute value bars. Step number 1 is to isolate them, meaning we have to eliminate that 3 there. Okay, so we'll talk about how we do that in a second, but just simply notice the difference. Problem number 1, absolute value bars are already isolated. Problem number 2, we have to do that. We have to accomplish isolating those, okay? Let's look at a couple other examples. Problem number 1 on the back side of this. Here are your absolute value bars. You have to isolate them. That simply means that you need to eliminate the 8. Once you do that, now they're isolated, right? Problem number 2, here are your absolute value bars. Step 1 says to isolate them. That means that we need to eliminate the 14 and the -2. Once you accomplish that, now they're isolated. Number 3, here are your absolute value bars. They are already isolated. So you can move straight on to step number 2, okay? So I just wanted to very quickly wrap your head around what it means to be isolated and not, okay? Because if the absolute value bars are not isolated, then you have to go and accomplish that. All right. So let me erase some of this. Let's go back to our notes. Let's continue taking notes here. So that's what step number 1 is referring to, isolating those absolute value bars. Once that has been accomplished, once they are isolated, you're going to write the equation twice. Write the equation twice without. W/O stands for without the absolute value bars. All right. So at that point, we're going to write the equation twice without the absolute value bars. Just write them identically. Step 3. Step 3. Step 3, this is going to highlight the reason that we write it twice, okay? The answer in the second equation takes a negative. The equation in the second equation takes a negative, right? So I'll point that out for you, and we'll do that step together multiple times. Once we give that answer to the set, because remember, we're writing it twice, so we have the original, and then we have the copy and paste of that same equation. That second time we write it, we're going to give the answer a negative. That's the only difference the second one takes. And then step 4, oops, solve both. So this simply lets you know that each problem for absolute value equations, each problem is going to have 2 answers. All right. So let's jump into this. Let's look at problem number 1. If you guys need to pause that in order to write all that down, feel free to do that. And then you can hit resume or play. All right. Problem number 1. We want to isolate the absolute value bars. As I mentioned earlier, these are already isolated. Okay. Now, once you've isolated the absolute value bars, like example number 1, now we move to step 2. Write the equation twice without the absolute value bar. So here I'm going to write negative 2x plus 7 equals 25. Now I'm going to go and write it again. Negative 2x plus 7 equals negative 25. All right. So actually, here, notice I simply wrote them both identically. Okay, so this was step number 2, and you'll see how quickly you'll be able to do step 2 and 3 together, right? Now here's step number 3. So I wrote them both identically, writing them both twice. Step 3 says that the answer in the second equation takes a negative. So notice each of these equations have an answer because they're being equal to 25. The original that it was equal to was a positive 25. The original will stay, but the second, this is the reason that we write it 2 times, is going to take a negative. So you should have one equation that is exactly identical, and then your second equation should be equal to the negative of that number, whatever the equation is equal to. Okay, so here it's negative 25 that we're going to equal it to. So that's step 3. Now step 4, we simply solve both of these equations. Right? So I'm going to drop this line here. We want to ask ourselves, what is the first thing that we do when solving an equation? That's identifying the side the x is on and eliminating the constant. The constant is the number that is being added or subtracted from that variable. So we want to eliminate 7. Negative 2x is equal to 25 minus 7 is 18. Last step, side by side, the -2 and the x are side by side, so we must divide. Divide by -2, x equals -9. This is one answer, okay? Now we have to simply solve the second, all right? So here, we're going to go here now. I'll go ahead and tell you the biggest common mistake that students make when first operating or doing absolute value equations is assuming that the answer to this next one is going to be a +9. Doesn't work that way, okay? Because we have our first equation that's equal to a +25. This next one being equal to a -25. Notice what it does right off the bat. Still going to do the same thing first. We're going to subtract 7 because that is my constant. Anywhere we see a constant, always eliminate it first. Now notice this does not become a -18. This is why your answer is not a +9. Because a -25 minus 7. Remember, you're on -25 on the number line. Whenever you subtract, you're moving down that number line to the left. Okay? So it's your -2x that drops, but -25 minus 7, that's going to give you a -32. Okay? A -32. Now we have side by side, so we can divide. Okay? That -2 and the x are side by side. So we're going to divide by that -2 there. -32 divided by 2 is going to give us a +16. Both of these are your answer. All right. So for each one of these, like I said, we're going to have 2 answers. Now let's go ahead and move on to example number 2. Remember, step 1 is to isolate the absolute value bars. These absolute value bars are not isolated. There's a 3 on the outside. Okay. Now, how do we eliminate that 3? Because again, we have to think through, if I need to isolate those absolute value bars, that means that I need to get rid of that 3 somehow, some way. Well, the way you do that is do the opposite of whatever the 3 is doing to the problem. The 3 is side by side with those absolute value bars. That means 3 times the absolute value of 4 minus 2x. So therefore, we have to engage the opposite of what it's doing, the opposite of multiply. Remember, side by side is to multiply. So the opposite is to divide. We can divide that by 3 and it will eliminate it. It means we have to divide this other side by 3. Now we have successfully isolated the absolute value bars. 18 divided by 3 gives us 6. Now we can move to step 2. That was the isolation of the absolute value bars. So only when you have the absolute value bars by themselves can you now write it twice, okay? So because we isolated those, now we can go over here and write this equation twice. And when you write it twice, write it without the absolute value bars, okay? Now step 3 is to give the answer of the second equation the negative, okay? It's the only difference. That's the whole reason for writing this twice. Now we solve both. Look at the one on the left side. We need to eliminate our constant. The constant is that 4, so we have to subtract 4. All right, so this allows -2x to drop, and then 6 minus 4 is 2. Side by side, you must divide. Divide by -2, and x is -1. All right. Come over here. We've got 4 minus 2x equals -6. So again, same idea. We just want to solve for x. We've got 4 minus 2x equals -6. Or 4 is our 4 is our constant, so we're going to subtract or eliminate that constant. -2x is equal to a -6 minus 4. See, this is the reason that we're getting different answers, because -6 minus 4 is not 2 or -2. We're on -6. We have to go left down the number line 4 more times. This is a -10. Side by side, you must divide. The negative divided by a negative is a positive, and this is a +5. So your answer is both -1 and +5. All right. Now, here's what I want you guys to do. Take these two examples that we have just done together and your notes of these steps 1 through 4. I want you guys to flip this over on the back, and I want you to attempt. I want you guys to try these 3. Press the pause button, and then we're going to come back together and we're going to do these together, okay? All right, so hopefully you guys did, or at least attempted those, okay? So let's walk through these together, and you guys kind of look at these in hindsight and ask yourself, what could you have done? What did you do wrong? What can you learn from that, right? All right, looking at problem number 1. Step 1 says to isolate the absolute value bars. Here they are not isolated. These are your absolute value bars, and you have +8 still being added to your absolute value bars, okay? So that's the first thing that we want to do, is eliminate this 8 here. We're going to subtract 8 on both sides, and that will give us the absolute value of 5x minus 6. And that will be equal to 24. 32 minus 8 gives us 24. Now we have successfully isolated the absolute value bars. Now we can write it twice, okay? So I'm going to write it up here. 5x minus 6 equals 24. And then the second time, 5x minus 6 equals a -24. Remember, when you write it the second time, it's the answer of the second equation that takes that negative sign. So now we just simply have to work and solve both equations. 5x minus 6, that minus 6 is our constant, so we're going to add 6 to eliminate that. 5x drops. 24 plus 6 gives us 30. Side by side, you must divide. 5 times x, the opposite of times is to divide. So here, x equals 6. 30 divided by 5 is 6. Do the same exact thing on the other equation. Eliminate the constant first, as always. So we will add 6 to both sides. 5x is equal to -24 plus 6. This is going to give us a -18. If you guys need to use a calculator when adding and subtracting positive and negative numbers, by all means do it, okay? Those are rules that if you're going to do it by hand, you have to be very familiar with, or else you're going to be losing a lot of time. Because if you guys can, you can already tell we're solving some much more complex problems than just focusing on adding positive and negative integers, right? This is about learning absolute value equations. So if you need that extra assistance, that extra tool of the calculator to do negatives plus positives, by all means use them. But in reference to that, remember, whenever one number is a negative and the other is a positive, The answer, your sum, takes the sign of the larger number. So between 24 and 6, the larger number is 24. Therefore, we know the answer will be negative, and then you have to take the difference. So the difference between 24 and 6 is 18. All right, side by side must divide. So we're going to take that divide by 5 on both sides. And here we are going to get a decimal. This is very common with absolute value, okay? This is going to give us negative 3.6. Decimals are very common with absolute value problems. So if you're getting a decimal, don't fret, don't worry about it. It's very common, okay? All right, that's problem number 1. Let's go ahead and look at number 2. Step 1 says to isolate the absolute value. So as always, and as we typically do, the first thing you want to eliminate is the constant, all right? So here we're going to subtract 14 from both sides. This is going to leave us with negative 2 times the absolute value of 2x plus 3 is equal to negative 16 minus 14 is going to give us a negative 30. Okay. Now we need to continue to work towards isolating those absolute value bars because they're still not by themselves. The negative 2 is side by side with the absolute value. It means that they're being multiplied. We have to do the opposite. We have to divide. So here we divide by negative 2. That leaves us with the absolute value of 2x plus 3 is equal to a positive 15. All right. Now that we have isolated the absolute value bars, now we can write it twice. So I'm going to come up here at the very top. I'm going to write 2x plus 3 equals 15. I'm going to write it again. 2x plus 3 equals, we're going to make this one a negative 15. Remember, the answer to the second equation becomes negative. Now we simply work and solve both. So for the first one, we're going to eliminate the absolute value bars. Eliminate the constant, which is that 3. So we'll subtract 3. 2x drops. 15 minus 3 gives us 12. Now the 2 and the x are side by side. When we see side by side, we must divide because they are currently being multiplied. Here, x equals 6. Come back up here. Subtract 3 because that is our constant from both sides. 2x. Now negative 15 minus 3, this gives us a negative 18. Side by side must divide. X is going to be equal to a negative 9 for that one. So x is both positive 6 and negative 9. All right, last one, problem number 3. Notice the absolute value bars are isolated. There's nothing on the outside of those absolute value bars. So we can go ahead and jump to step number 2, which is to write this. Write both of these twice. And that 17 is going to take on a negative 17. All right, what's the first step? Will always be to eliminate the constant first. Constant that is over there with the variable, whoops, sorry guys, is a negative 5, so we have to add 5. Add 5. So 2/3 x is equal to 22. Now, at this point, once again, remember what fractions are. Fractions are division problems. This literally reads 2 divided by 3. Always, okay? So all we have to do is do the opposite of dividing by 3. Here, anytime that you need to eliminate a fraction and you're working an equation, all you have to do is multiply by the denominator, because multiplication is the opposite of a fraction. So watch what happens whenever I eliminate this by multiplying by the denominator. I get 2x to drop down. All I have to do is, if I multiply by 3 on the left to eliminate the fraction, I just simply must multiply by 3 on the right. 22 times 3 is 66. Now, side by side, we must divide. Divide by 2, divide by 2. X equals 33. There we have it. All right, now we'll just simply do the same thing for the other side. Eliminate the constant by adding 5. We've got 2/3 x is equal to a negative 17 plus 5. This is going to give us a negative 12. Now, once again, anytime you need to eliminate a fraction, multiply by the denominator. Makes things super simple. 2x drops to become 12 times 3, which is negative 12 times 3. That's a negative 36. Side by side must divide. Here. That's going to give us a negative 18. Very good. Awesome. All right, guys, that is absolute value equations. What I would like for you guys to do is go ahead and look through and work on the corresponding worksheet. Okay, notice that these are multiple choice, so at least you have that going for you. Now, if you begin to get decimals, which you will, okay, especially if you're using a calculator, most of you guys are going to want to do it that way anyways. As you're getting decimals, if you notice, none of the answer options are in decimal format. It's not that big of a deal. If you simply remember that all fractions are division problems, check this out. 58 over 5 is truly 58 divided by 5. If you put that in your calculator, 58 over 5 translates to 11.6. Now, I'm not telling you that to insinuate that answer or option B is the answer, because I really don't think it is. But as you begin to get decimals when you're working these out, that's all you have to do to keep in mind, okay? What I would do on problem number 2 is literally convert all of those fractions to a decimal. So here, I would make that negative 13 divided by 6, negative 49 divided by 3, negative 12 divided by 5. Okay, I'll do this with you. Notice what I just did to convert this. I discounted the fact that the negative was out to in the middle. Anytime you need to break a fraction down, the negative should always belong to the numerator. All right, so we'll take this first one, negative 13 divided by 6. This answer option would be a positive 2 and negative 2.16 repeating, okay? Now answer option C. Negative 49 divided by 3, this is going to give you negative 16.3 repeating. And then D, answer option D, you've got negative 12 divided by 5. This answer option would be negative 2.4. So if you're working decimals, convert those answers, those fractions into decimals, and then work out that absolute value equation. All right, guys, work on this. The absolute value answer key is in the classroom. Send me any questions that you have about this lesson. I'll be more than happy to help you through it. See you next time.